Good morning, everyone. I am Pradeep, and today we will explore how an event driven observability layer can finally light up the blind spots between ECAD and MCAD teams. Think of this session as journey from today's file drop headaches to a future where design changes surface in real time. Before they burn either schedule or budget or both. Here is a map. We'll begin with collaboration gap. Why late found issues are still the norm. Then we'll define the event driven vision. We'll unpack three core building blocks named schema, audit, and library sync, and two cross cutting enablers, taxonomy and resilience. A quick architecture walkthrough shows how it all fits. We look at pilot projects, technical and business KPIs. Finally, we'll touch on monitoring roadmap. By the end, you will see exactly where to start your own tool chain. Let's ground the problem. Even in 2025, most hardware programs pass files between ECAD and MCAD at a gated milestones. A study across 8 boards found over 10 snapshots per spin. Each snapshot a potential rerouting. Industry data shows that late reworking inflates cost 8 to 10% and drags schedules 4 to 6 weeks. People end up in detective mode. Which file version, which variant, who changed the keyport. When that fog sets in, design energy shifts from innovation to forensic triage. That's the gap we must close. Hope you all agree with me. Here is a story you will recognize. Mid program, mechanical changes a chassis read by 3 millimeters. Yeah, it's just 3 millimeters. Keyboard shrinks, but ECAD keeps routing blissfully unaware. A week later, DRC screams, and suddenly you are starting at a 250K respin and a 6-week slip as a sample numbers. Root cause isn't bad tools. It's timing of information, isn't it? The insight actually arrived too late to matter. So, why events? First, they are push based. A tool emits a lightweight the instant something meaningful happens. Second, events are context rich. They bundle geometry hashes, user IDs, variant tags. Third, context leads downstream check file automatically. And third, event flows through a broker that is resilient. If MCAD is down, ECAD can keep publishing the system replays once MCAD is back. The bottom line is decision that used to wait days now happens in minutes. Our first building block is a shared schema. Every ECAD change or MCAD update follows the same contract: item ID, revision ID, geometry hash, user timestamp. Optional blocks capture CC variants for BOM options. Tools validate locally. Malformed events never leave the workstation. Consistent structure is what lets hundreds of tools speak one language without spaghetti code. Second, audit logging. Every event also lands in an immutable store. We track general workflow, security, file access logs, who changed what and when. These logs cut your cause time from hours to minutes and satisfy the traceability mandate in medical and automotive hardware. They are exportable to CSV for compliance reviews No more screenshot archaeology. And it's library sync. Third, library synchronization using EDA library.xml. We run export library, sync library, and multi-revision check-ins. That keeps symbols and footprints aligned across tools like Arcad, Allegro, and NX, where they live. The status file success flag becomes another event. So, analytics can spot a stale footprint before it sneaks into a schematic. Now we layer two cross-cutting enablers. Geometry events. Board outline, keyports, mounting holes. Component events like placement moves, part swaps. Analysis events like TFM or thermal rule results. During the projects, lightweight heuristics, nothing exotic, mostly DDOM and debots. Cut irrelevant charter by 54%. That means engineers only see the signal, not the noise. Of course, events are great until something starts. So, we embed back pressure and replay. If MCAT goes offline, the broker queues safely and replays on recovery. Compensating transactions, rollback, partial writes. A checksum verifier blocks corrupt payloads, and a circuit breaker isolate flaky PLM APIs. The net result, observability you can actually trust at scale. Putting it together, ECAD and MCAD publish into a Kafka broker, stream processor compare events, geometry deltas, and bomb differences, kind of. Violation go to dashboard and chat channels. The audit store captures everything for legal traceability. This isn't a science project. These components are all off the shelf. Here, how a keep out violation plays out. MCAD publishes an MCAD update rib added. Stream processor compares geometry hash, keep out stack. Rule engine flags out of bounds. MCAD both get a Slack ping with a 3D overlay. Minutes after the change, not days. Yes, that's the magic. Instant, context rich feedback. Let's look at the numbers from pilot board changes. Revision lead time dropped from 7 days to 3 days. Second example, part number approvals from 4 down to a day and a half, and board spins fell from 3 to 2. Those are schedule wins your CFO can bank. On the business side, time to decision, snapshot count, and conflicts resolution all improved by 60 plus percent. Less churn means fewer Friday night scrambles, lower NRE spends, and happier engineers finally, which your HR metrics will confirm, right? Observability can't be blind to itself. It tracks events volume and broker lag. Active Workspace shows 3D deltas. Kibana lets you grab every payload. Server monitor config watches for BB connection losses and deadlocks. Ping offs only when threshold are breached. That's how we keep the pipeline healthy long after launch day. Rollout in 4 phases. Phase 1, capture bomb, outline events, low noise, instant value. Phase 2, add constraints and variant events. Phase 3, inline DFM and thermal checks. Phase 4, feed suppliers and manufacturing within the same streams. Each phase is incremental. You harvest ROI, return on investment, before moving on. A few scars to save you your pain. Start small. Too many events too soon erodes trust. Govern schema versions. Yep, nothing breaks integration faster than silent field changes. Align ECAD and MCAD naming conventions on day one. Invest early in broker observability like lag matrix or your early warning radar. Thank you. That's the journey from blind spots to real time clarity. Thanks for lighting up the room with me. Have a wonderful rest of the day.